first page of Note Packet 9, at the top of it is basically the theme of what this entire note packet is about, linear equations. What you have up here is a linear equation that is in slope-intercept form. Y equals mx plus b. You'll notice that the x and the y are the placeholders for the independent and the dependent variables, just like they're labeled. And then what we do is we have the slope here in the spot that we use m for a placeholder, and the y-intercept in the spot where you see b. In order for you to be able to understand this better, I want to make sure that as you're identifying the slope and the y-intercept in a linear equation, you understand that the slope is just represented by a number, and that number is whatever is paired with the input variable or the independent variable. The y-intercept also is expressed as a number, but it's a number that is embedded in an ordered pair. So if you're talking about the y-intercept, that ordered pair should start with the number 0, because you're going 0 units to the left or right, and then whatever you have for b goes in the spot that is y in your ordered pair. If you look down here at the bunch of examples that I have, for the very first one, it's asking you to identify the slope. Y equals 3x minus 2. 3 is in the spot that is paired with the independent variable, so 3 is the slope, positive 3. The y-intercept, you're always going to open up your ordered pair, start with 0, and then the number that is in the spot that is b would be the y coordinate of your ordered pair. So this y-intercept is 0, negative 2. I want you to pause your notes, pause the video, complete the rest of the examples, and then come back and compare your answers with the answers that I give you. So now is a good time to pause. The second example, your slope is negative 2, your y-intercept is 0, 5. The third example, your slope is 1/2. The y-intercept is 0, 3. The third example, your slope is negative 2. Your y-intercept, even though you don't really quite see it here, is going to be the origin. If you don't have a number that you can see in the spot where you have b in your slope-intercept form, then you can assume that there's a 0 in that spot, so the y-intercept is the origin. The next example, if you notice, you don't have independent variable in there. And basically, if you did rewrite this with an independent variable, it would look like y equals 0x plus 6. The only time when you ever have y equals and then just a constant number would mean that you have 0 slopes. So 0 would go in the slope spot, and your y-intercept would be 0, 6. The next one, your slope is 3.5. That's what's paired with the x. Your y-intercept is 0, 9. The next one, your slope is 8. Y-intercept is 0, negative 25. The last one is not even in slope-intercept form, but to put it in slope-intercept form, I would have to take 5 away from both sides. Now I have it in y equals mx plus b form. I can interpret that the slope is going to be negative 3, and the y-intercept is 0, negative 5. On the next page, we're going to look at a combination of a practical problem that is utilizing slope-intercept form, and at the same time, we're kind of briefing on practical meanings in function notation. The example that you have here deals with housing prices in a neighborhood that has been steadily increasing since you purchased your home in 2009. The relationship between the market value, which is represented by V of your home, and the length of time, represented by X, you have owned your home, is modeled by the symbolic rule. So V of X equals 2,500 times X plus 125,000. Again, V of X is measured in dollars and X is measured in years. The first question says, explain why you would expect the graph of the symbolic rule to be a line. What is the slope of the line, and what does the slope represent? I want you to think for a moment here if there was an x and y axis and you were plotting the y-intercept. Remember that in slope-intercept form, the y-intercept for this would be 0, 125,000. Remember also that the x represents time and the v of x represents the value of the home in dollars. So here it is. I'm just going to plot an arbitrary number, arbitrary point 0, 125,000. The next year after that, the growth of this home, the value of the price of this home is going to grow by $2,500, and every year it's going to grow by $2,500. So you can see that this is steadily growing. It's a constant rate of change. So I'd expect this to be a line if you were to graph the value of that home measured over time. I also would say that I would expect this to be a line just because it's in slope-intercept form. So if you have it in slope-intercept form, your variable is an x, not an x squared, not an x cubed, then you can expect it to be a line. Again, remember that the slope of the line is whatever is paired with the independent variable. So in this case, the slope of the line is 2,500, and that slope represents how much the home increases in value every year. That's a practical meaning. It means that you're describing what the slope means in context of the problem. B, what is the y-intercept? In this case, the y-intercept is 0, 125,000. And what does the y-intercept represent? This is funny because it's like an ordered pair, and you know that the x value represents time, and you know that the y value represents the value of the home. You could basically write this in a sentence and be able to describe what the y-intercept is. Since year 0 represents when you purchased your home in 2009, you could say that it represents that in 2009, the value of the home, the starting value, was $125,000. If you were asked to find the v of 8, what is the practical meaning and what is the value of v of 8? It almost is kind of self-explanatory. V stands for value. 8 is representing the input variable, and the input variable is time. So 8 must represent 8 years after you've purchased the home. If you purchased the home in 2009, 8 years after 2009 is 2017. So this question is asking you to find the value of the home in 2017. I basically would take 8 and plug it in for the input variable and figure out what the output would be. If each year is 2,500 and I multiply that by 8, that would give you 20,000. So in 2017, this home would gain $20,000 in value, which would make it $145,000 in value. Looking at the next examples, given the linear function y equals negative x plus 4, they want you to identify the slope and the y-intercept, just like you were doing on the graph before. The slope here is the number that's paired with the independent variable. It's -1. The y-intercept is 0, b, and the b is 4. The second part of this are the following ordered pairs solutions to negative x, y equals negative x plus 4. The only way you can tell if something is a solution is if you plug the numbers in for the independent and dependent variable and you end up with a true statement. For instance, if I have, again, y equals negative x plus 4, and I plug 5 in for y and -1 in for x, two negatives next to each other with nothing in between become positive, so 5 does equal 1 plus 4, so this one is a yes, it is a solution. I'm going to try this again, because I know that there's more than one ordered pair that's going to work in this. Let's see if it works. So I'm going to plug 1 in for y. I have 3 that I'm plugging in for x. 1 equals -3 plus 4. Yes, -3 plus 4 is 1. This is a solution. The next one, if I plug 9 in for y, and 5 in for x. 9 does not equal negative 5 plus 4, so this is not a solution. Determine an equation of the line whose slope is 2 and whose y-intercept is 0, negative 3. Remember that the slope is a number you plug in for m. The y-intercept has a y-coordinate that gets plugged into b. So using y equals mx plus b, I'm plugging in 2 for m and negative 3 for b. This is your linear equation. Determine an equation of the line whose slope is negative 3 and y-intercept is 0, 0. Plugging in negative 3 for m. There's no y-intercept. I can put plus 0 if I want to, but it would look kind of dumb, so I'm just going to leave it like that. And a C, determine an equation of the line whose slope is 3 over 4. It contains the point 0, 1. This point happens also to be the y-intercept, so I can write y equals 3 over 4x plus 1. The steps to graphing a linear equation are on the top of this page. I'm going to keep repeating them over and over, but if you ever need to go back and look at them, everything that I'm going to say is going to be written there in steps. What we're going to do is, given a linear equation, we're going to go ahead and draw the line on a graph that represents each of these. If you look at A, the very first thing you have to do, if it's not already in the proper form, y equals mx plus b, is you're going to have to make sure that you've put it in that form. So if it is in any other form, you're going to have to solve for y, make sure it's in y equals mx plus b form. Then the next step would be to plot the y-intercept. So in this case, the y-intercept is 0, 3. So I'm going to start at the origin and go up 3 points and plot the y-intercept. I can make a line that has a slope of negative 1/3 anywhere on my graph, but if I want the specific proper line that goes with this equation, I need to figure out exactly where on that graph my line's going to be. So starting at the y-intercept, I'm going to use the rise over run mnemonic that we've talked about before. I'm going to go ahead and put my negative symbol with the bottom number, although it wouldn't be wrong if I decided to put it with the top number. I just have to pick one. I can't put it with both, because if I do, it's no longer negative. A negative over negative is positive. So here I am at the y-intercept. I'm going to rise positive 1. Then I'm going to run 3 units in the negative direction, and there's a second point. If I do it again, rise 1, run negative 3, there's 3 points. I can go ahead and draw a line. Oops, I forgot this is not like I actually really have to draw a good line. This is not Notability. I'm going to sketch this line to the best of my ability. Wow, that's awful. There it is. The last thing that you have to do after you draw a line and draw arrows is you label it. Oh goodness, I hope you guys have rulers, because that's really bad math manners to draw poor lines like that. Alright, looking at B, I have to plot the y-intercept first. The y-intercept in this case is the origin. My slope is 5 over 3, so I rise 5, run 3, make a point. Now I've got 2 points. I can go ahead and draw my line. Y equals 5 over 3x. Looking at C, my y-intercept is 3. Here it is. My slope here is negative 6. In order to do a rise over run, I'm going to have to put this negative 6 in fraction form. In this case, I'm actually going to put the negative with the rise, because I actually can't rise positive 6 and stay on my graph that I've been given. So what I'm going to do is I'm going to rise 6 units in the negative direction, which is kind of a contradiction, but hopefully you get the mnemonic and how we have to bend it to our will. I'm rising 6 units. 1, 2, 3, 4, 5, 6. I went down 6 units. 1 unit in the positive direction. There is my slope of negative 6. A very steep slope going downhill, just like we would expect. Yeah, so that's C. For D, My y-intercept is -2. My slope is rise 7, run 2. If I rise 7 and run 2, my next point would be right here. Draw my line, arrows, and every single time, hopefully I don't ever forget, you should label your line. There are 4 more examples on the next page, so what I want you to do is I want you to pause the video and then do the next 4 examples. Actually, do the next 2 examples. I'm going to do the last 2 with you, and then come back and see if you got them correct. For E, your y-intercept is -2. Your slope is rise 1, run 2, rise, run 1, 2. Here is your line, y equals 1/2 x minus 2. For F, your y-intercept is 5. I want to rise 2 and run 1, but that takes me off my graph. A thing that you can do if you want to be able to plot points on your graph and you're kind of limited is you actually could do the rising and the running but going in the reverse direction. So I can rewrite 2 over 1 as -2 over -1, rise -2, run -1. If I wrote negative over negative, I end up with a positive, and it allows me to go in the opposite direction where I have lots of space in my graph to draw. Y equals 2x plus 5. That was some major manipulating to make something work, and you know, it's a good tool to have in your back pocket if you're ever limited with the kind of graph that you're given. For G, you have a special case here where you have y equals and then a constant number. In this case, that constant number is -5. -5 on the y-axis happens right here. Anytime you see an equation that starts with either x or y and it's equal to a constant number, it means you either have a horizontal line or a perfectly vertical line. To know which one you have really depends on what letter you have that is equal to the number. In this case, it says y equals -5. That means that this line is going to go through -5 on the y-axis, and it is going to pierce the y-axis. I'm kind of showing you right now how we're piercing the y-axis. This is the line y equals -5. A lot of people find this really confusing because they think that if it says y equals -5, it should be parallel to the y-axis, but it's actually the exact opposite. It means that it's piercing the y-axis. For H, x equals 5. That happens right here on the x-axis. That means that this line is going to pierce the x-axis at 5, and it's a perfectly vertical line. And we're going to label it, and these are some special cases right here. Special cases. It's pretty cool. That is the end of this note packet. So if you have any questions, please post them in Schoology.